So first, we'll talk about what is robot. Like when this word comes into our mind, no, like the robot. First, we thinks in the terms of human. Like it is something that act like a human. It is like talk like human, or it do activities like human. Okay, the simple example is our GT Robot 2.0. In that, Rajinikanth is acting like a robot. Okay, so first thing that comes to is like a human, but actually this is not only robot is not defined to this separate section. So we call it as humanoid robot, and this robot or robotics is become very good interesting nowadays. Like it is very interesting topic. Why? Because the human itself is a complex system. Okay, and when we are replicating or when we are taking a prototype of human, it is a very interesting topic. But the robot is not it is not restricted to only this humanoid robot domains. There are like different types of robots. Okay, so why this human form that comes into our mind? It is due to the fiction or fictitious characters that is came on movies. Okay, there are a lot of movies which shows a robot in different forms. You can see in the picture. Okay, there are a lot of characters here, and even with a humanoid form or with a normally like moving robots or some other fiction characters. But in fact, the robot are defined as a man-made mechanical devices, okay, that can move by themselves, whose motion must be modeled, planned, sensed, actuated, and controlled, and whose motion behavior can be influenced by programming. Okay, so with a programming or something system which can be reprogrammed also. Okay, that is a robot. That is the explanation. That is the definition for robot. And like every robot should follow or these three laws of robotics. Okay, these are like three laws which is globally accepted. Okay, the first law is says that a robot cannot harm a human at any stage. Means it is not allowed to harm a human at any stage. That is the first law says. Okay, the second law says that the robot should obey the human orders. Means whatever the human says through the program, or like if you say human robot, what the human gives the input, human says to do the work, the robot should follow that work or that order, but without harming humans. Means without violating the first law. Okay, the third law says that a robot must protect its own existence, but by without violating the second law and the first law. Means it should protect its own existence, it should obey the human orders, and it should not harm humans. That is made the general law says for the robotics. And the types of robot, if we see, mainly we can classify in 5 groups. Okay, these are like main classifiers. There are different type of classifications. Okay, first we talk about this main type of classification. In that we have mobile robot, industrial robot, autonomous robot, remote control robot, and virtual robots. Okay, in that if you talk on mobile robots, you can see an example in the picture. That is a KUKA U-boat. Okay, so mobile robots are able to move. Usually they perform tasks such as searching or transportation, etc. Okay, means something used for transportation or searching, which moves. It is not a standalone. It's not fixed anywhere. It can move. Okay. In that there are 2 classifications. Okay. One is rolling robot and another one is walking robot. So in the name itself, it is clearly explained. Rolling robot means it is having wheels. It can roll. It can move with wheels. Okay. And see, the wheels are not only rotational. Means it can move on like a straight and left, right, and in an angle also it can move. Okay. That is the specialty of this wheel. And we can say it is usable only on the flat areas, because if it is going on like off-road something we say in vehicles like that, when you go like it's not in flat areas, you may require walking robots. So what is walking robot? Walking robot is having legs. Okay, it can walk, and the first robot which was shown, humanoid one, or the Chitty robot, that fiction character itself, but maybe in future it can come. But that robot have a walking mechanism. Okay, but it is not easy to develop that mechanisms. Okay, so nowadays most of the robots will have at least 4 legs, or like four, more than that, 4, maybe 6 or something, because it is not easy to balance like a human walks, no, with 2 legs. It is not easy to balance. So nowadays it is having 4 legs or 6 or more, but even in future it can come with 2 also. So we have KUKA is having an industrial product with this mobile robot, we can say. It is OmniMove. Okay, OmniMove is a means a robot which is used to do the transportation. Normally in industries now we call AGVs also, automated guided vehicle. There are so much names for this. Okay, here OmniMove is used to do the transportation purpose. Okay, it can move like 1.5 ton weight. Okay, with like 2 or 3 OmniMove, it can do a parallel or coordinated works. Means if you have a 3-ton weight or if you have a train bogie, it cannot be moved with one OmniMove, right? So we have 2 or 3 in a coordinated motion. It can carry that much weight. Okay. So next type, if we say, that is like industrial robots. So industrial robot is the main thing that we are concentrating today. And industrial robots are the robots which is used on industry for a repeating task. Okay, if you have some task like maybe like welding or like laser cutting or cladding or maybe arc welding, so some repetitive production task, maybe handling. So these type of repeating production tasks, the robot is fixed in some place. Okay, we call it as a manipulator here, that is fixed in some place, and it will be repeating that task always. It means something like if I have some part to be welded, I can load that part to the robot section. Robot will weld and robot will give that part. And this type of robot, mostly it is concealed in a workspace. Means the safety to be checked, right? So you have a workspace which is closed workspace. In that closed workspace, the robot will be working. And here in the picture, you can see means a welding application. Okay, and it's a actually here if you see, there is a person standing inside the site. Okay, and this is a 3D friction welding. Okay, and the person is doing a programming. Okay, after programming he will come out and the robot will be doing that task always. So the same next example, you can see there are a lot of robots in one cell. Okay, here it can be used for handling, assembly, or some application cells like that. There are different type, different payload category robots. So next type is autonomous robots. So autonomous robots are something like which is having a brain, we say, but actually a brain means artificial intelligence is on like research only nowadays. We cannot fully, it is not fully developed. So what is developed is like machine learning. Means see, if there are like possibilities. So with respect to possibilities, the robot will choose the most suitable possibility, okay, for the result. Why we use autonomous robot in the means like means here we have given an example for NASA. See, you think that a robot we have sent to NASA, means this robot is a Discovery rover, okay, which was developed by NASA. It has been sent to Mars. Okay, so in Mars, the robot need to do some activities like it want to search the presence of water, all those things. So if the robot needs to move or some activity to be done, if we are giving a control from here, that signal can take up to 30 minutes to reach NASA. So if you give, if you send one action, if you send the robot to move on the left side, if you send that action here from now, it can reach there after 30 minutes. So it is not a possible way of solution. So the robot itself should take some decisions. Okay, so at that type of places, we can use these autonomous robots. Okay, and still research is going on these autonomous robots with the machine learning and artificial intelligence. There are a lot of researchers are going on this. So next one is remote control robots. Like some places you cannot means depend on the like robot brain. Okay, whatever the artificial intelligence or whatever maybe. Some risky places you cannot trust on the robot brain. So some example means some hospital cases, the robot is doing surgery with this thing. You cannot depend on robot for a human life. So what they are doing is, there a remote control robot options are there. Means you can use your brain, you can control your robot on live and you can do that actions. In the photo here, we have given an example for a rescue robot. Okay, and still remote control of robot also, there are a lot of research is going on. Something like we can say borewell rescue robots, and like there are so much rescue robots, all those things. I will explain it in the coming slides more. So next, the last type of robot we say is virtual robots. This doesn't have any existence, means it's not a physical form. Okay, these are like a program or just a code block. The main example, the first example we can say is Google search engine itself. So that is the main classification of robot. Okay, so we are concentrating on industrial robot. So there are mainly like 4 types of industrial robots. You can see on the picture: articulator robot, and SCARA robot, and Cartesian robot, and Delta robot. Okay. So KUKA is moreover KUKA, not only KUKA, all industrial robots moreover see towards on articulator robots. Why? Because articulator robots is having 6 degrees of freedom. Means it is having, like you can see the workspace which is mentioned here. In that workspace, it is having 6 degrees of freedom, different orientation, XYZ places, ABC orientations. So because of this, means every most industrial teams are going for articulator robot applications. But when it comes to cycle time means it's a time taken to complete one process, maybe a welding. Okay, to complete a welding means a cycle, that can be say a cycle time, or some other process, any process. Okay, the time taken to complete that process is called cycle time. So when you look towards cycle time, SCARA robot is having an advantages over articulator robot, and even Cartesian robot, and Delta robot is more means faster than our SCARA robots also. So KUKA is having product on articulator robot. SCARA we had before. Okay, and Cartesian robot, Delta robot, you can use our controller. Okay, it's not we don't have our own robots, but you can use our controller and you can design one robot by your own. So examples for articulator robot, not only KUKA, there are different manufacturers for articulator robot. Onisnachi and Fanuc, you can see the examples on the slide. Okay, ABB is there, Epson is there, Yashikawa is there, and KUKA. So here we have shown the KUKAs like IVA robot. That is our latest technology robot. Okay, this is like a collaborative robot. So first I will tell what is a collaborative robot. See, first when we shown that picture, with the robot there was a human working inside the cell. So in that, like if you see, it can means be a problem for the human. Means that was like for teaching. Okay, after teaching, what does the human comes outside and they put the robot in working. And if somebody enters the room again while the robot is working, the robot will trigger safety and robot will stop. Okay, why? Because the robot doesn't know if any human enters into that place. Okay, for industrial robots I'm saying. So it can hit the man and it can be a problem. So we need to take care of the safety while designing. But when you talk about collaborative robots are designed to work together with the human. Means if you have some applications like you need to work with the robot, maybe assisting a human is what called collaborative robot. Maybe so many people have seen Iron Man movie. Okay, in that Iron Man movie, he was designing something. He was doing R&D, and even there are some assisting robots. Okay, so in that type we can think it's a collaborative robot which can work with the human. So it is having high quality of sensors. When the robot touches a human, it will stop its actions. Or you can define with some hand actions, you can define what to do. So next we are looking towards a market that we are growing. So there are applications in military, industrial, commercial, and consumers. Okay. So mainly if you see commercial sites like restaurant, serving restaurant, means even in Chennai there are restaurants started where the robot serves the food. Okay, and consumer side like a quadcopter or something entertainment. These things also robot is evolving in nowadays, and industrial always, military also robots are evolving. Okay, and even if you see commercial and consumer, the growth also is very high. Rather than expected growth, it was gone very high. So in terms of annual installations, we say in 2020, like in this year or 2019, these are like in the blue, if you see, that is the actual one, and this one is expected, the gray is expected. So in 2018, if you see, 422,000 of units was installed. Okay, and in 2022 we are expecting 584,000 units of installed. These are like expected. Okay, it can go means more than that also. And if you see the annual installation in industries in 2016 and 2018, like we have automotive around 120,000 to 130,000. Okay, around that figure. Electric and electronics, metal and machinery, plastic and chemical, food, and all others may be unspecified. Okay, so here if you see the graph, the maximum robot installation was going on automotive industries. I'll explain you why that automotive industry was looking towards the robotics in the coming slide. So in terms of we look towards the means countrywide. Okay, in terms of we look towards countrywide in 2018. In 2018, China was installed around 154,000 of units. Means I'm saying thousands of units. It's not a small number. Okay, Japan 55.2 thousands, and even India was installed around 4.8 thousands of units. So if you see, still this is like a market rate on 2018. We don't have the latest information because it's a general information of robotics, all robotics, not only KUKA. Okay, so in India, even there are like a lot of opportunities for installing the robots. Okay, now Make in India, all these things are came. So there are like lot of opportunities, and there are lot of installations are going on the current. Okay, so why robots are so much needed in industry? We can just justify with a small mathematical problem. Okay, if you see 2 shifts per day for 20 years, like the rebuilding cost can become like $10,000. Okay, and the maintenance cost for 20 years can come around $13,000. Okay, and lubrication 3,000, unscheduled repair 10,000, and the power consumption 0.59 to 80,000 hours, around $47,200. So totally around $70,200 it can come. But same activity, if it done with the labor, okay, so $30 per hour into 80,000 hours, it may come around 2.4 million. Okay, dollar. So here, in terms of savings, we are saving around 2.3 million. So that is a big amount if we forecast towards 20 years. Okay, so that's why main thing the industry is going towards the robotics. Not only this, and we'll talk that in coming slides. Okay, so first we will go towards what is an industrial robot. Okay, so why that industrial robot has came? Like you can know, you will be knowing about CNC machine. CNC means computer numerical control machine. So normally in first stages, like we had lathe, milling machines, all those things. Nowadays these machines are converted into CNC milling, CNC lathe, all these machines. Why means CNC is having a numerical control, a control machine. Okay, it is controlling the servo, and in terms of servo is controlling the mechanical movements with the high accuracy and precision, accuracy and repeatability, can say high precision it is controlling. So that's why the CNC got populated. And when in terms of tele-manipulation, if you see, like there are like mechanical linkages or mechanical arms, like our arms, like design thing, which was like controlled by externally. Okay, so we have these things, CNC machine and tele-manipulation. If we add the principle of these two, like CNC's principle plus our mechanical tele-manipulator principle, we can come into a picture of our industrial robot. Okay, so robot is having a mechanical arm, okay, which can be controlled through program, and which is controlled by some programs or servo motors. All these principles come to industrial robot. So it's a computer control manipulator. Okay, that is industrial robot. You can see an example for the industrial robot in the picture. And what are the advantages of using industrial robots? So main thing is that efficiency, increased efficiency, and improved quality, okay, and high repeatability of products. Means you are making one car, or you are an automotive sector, you are making one car, and you will be having some specified, like some welding is there in that car. Means you will be having some specified parameters for that welding. You will be having, you require a repeatability of product. You cannot come product one car in one way and another car in another means a dimension. So repeatability in terms of dimension, color, and the size, and every part should have the repeatability in the production. So in terms of, if you see repeatability, quality, the industrial robot gives very good quality and very good repeatability. Okay, so even it can work on hazardous environment. Hazardous environment in the means, I heard that in COVID, this COVID-19 pandemic, there are robots which is used to clean the streets in some countries. Robots is used to clean the streets and park, etc. So at these conditions, it is not easy for human to come out and do these actions. So there we require the robots. Okay, and in terms of industry, if you see, like a Tata Steel or some places where the steel is like melted at high temperatures. At these temperatures, working for a human is very difficult. Okay, so there at these hazardous situations, or we can say that radioactive elements, handling a radioactive elements, these are like hazardous for humans. At these places, we can easily use our robots. Okay, and like longer working hours, it can work like without any problems. 24/7 it can work. It won't complain you for working. Okay, and next we reduced investments. That I'll come on the next slides. Why this point I'll explain on the next slides. Okay, and reduce cycle time. For a time taken for the process will be reduced. Less requirement of skilled labors. Like if you are taking an application of welding, there with respect to the skill of the labor, the quality will increase. Okay, but here for the robot, we don't want that skilled labors. The robot can itself, we can do the program to increase that quality. Okay, and adaptive of the production requirement, flexibility I'll come on the next slide. Okay, easy modification of parameters. Like you are doing a welding and there are like some current or some voltage is mentioned on that, but the quality is not enough. You need to increase the welding parameter with a one small step. You can increase how many numbers of robots is there. You can increase in all that robots with some small steps, the parameter increasing. Okay, so greater safety. So in terms of safety, it is good. And reduced direct labor cost. Okay, reduced wastage of resources. So these are the advantages why we are going for robot in industries. Not only automotive, all the industries. That applications we will come in the coming slides. So next, if we see production methods like mass production, batch production, piece production, there are three types of production. And mass production is nothing but you are producing one part for a long run, maybe 1 year, 2 year, 3 year. You are producing the same part, same part. Okay, so you can invest on a machine that is utilized only for that process. Okay, maybe SPM, it will only weld that process. Okay, because you don't want to change that, just supply the material, get that product for 1 or 2 years, whatever it may be. So that is mass production. In terms of batch production, it is something like you know that in 3 months nowadays, in 3 months we are getting one model of car. Okay, so you can, the automotive industry cannot invest machines which is used only for one type of car. Means I'm producing Maruti 800 means. I cannot invest only for Maruti 800. Okay. In future, if Maruti another models comes, the line can be easily convertible for that models also. So there the robot comes into picture. Okay. In robot, you can, by changing the changes in the program, you can suit that lane for another type of cars. So nowadays there are different models are coming. So robotic systems are mostly implemented online, and which can be modified for another type of cars. Okay, next type is piece production. Piece production in the means it is like one piece only required, research and development, like 3D printing. Okay, even in 3D printing, there are like robots which you used to be able to do additive manufacturing or sculpture making. Okay, so with easy programming methods, you can use it for piece production. Easy programming means you can simulate the program on your screen and your laptop, and you can just deploy the program. So even mass production, because of the reliability and flexibility, we don't know that mass production can be gone after 1 year. So even most of the industrial peoples are investing on robot application due to this. So that's why, because of that flexibility and reduced investments, means you don't want to change always. That comes also into the advantages of using a robot.
Yeah, thanks, Vipinji. Hope everyone are there. So it like we have very less time now, so we need to complete as soon as possible. Okay, so please like everyone remember this. Like an average human hair is having a diameter of 65 microns. You just remember for a moment. So in next slide you can see that yeah, industrial robot. I'm specifying here industrial robot can have a repeatability till 20 microns. It means like it is very precise. What you mean about repeatability? So this is why we are going to choose industrial robot specific for our industrial applications like machining, painting, deburring or cutting. These kind of applications need repeatability. So that's why we need highest repeatability as possible. So we are going to choose industrial robot. You know why industrial robot is there. The main characteristics here is about its repeatability. You can see in the picture point P1 and P2 will be always repeated. Always means at every cycle, after every cycle, those points will be repeated with the repeatability of 20 microns. So you just remember this thing. So when we move to next slide, you can see that what is the architecture of an industrial robot. So here we have two main architecture. One is control box and another is manipulator. So when you say about like control box is nothing but it is having a components like PC unit. It is going to be having a OS inside that, and then some electronic components. Like controller will be having some input supply, 3-phase input supply or single phase input supply depending upon the robot. And then we will be having motor drive. Motor drive is responsible for, it's an electronic component which is responsible for running servo motors. And this will be, please note that this will be closed communication, so that like we are continuously getting feedback from servo motor, and we are then manipulating that motor in order to get our end effector at preferred position. Yeah, so this is like we are talking about architecture of industrial robot. Even though we have some super fast internal communication bus, it means like we need some communication channel which is at very high speed, and that channel is used for connection between motors like manipulator motors and control box. Another category we call them as field bus. Field bus is again another category of communication. So field bus you will use for communicating with external sensors, because robot is just a part of entire robotic system. Means we are just a part there. We need to communicate with our peripherals. That's why we need field bus also. So who are the industrial players now in the market? When we look towards industry, then when we look towards industrial robots, who are the players there? So mainly there are three players right now. They are like robot manufacturers, system integrators, whom we call again system builder, and end users. So here I will give an example that consider you want to build a house, and so it means you are owner, and owner is nothing but here end user. So you will not start building home yourself. You will give order to someone. Someone means builder, home builder, or a contractor. So contractor here is nothing but system integrator. And when you give this task to contractor, what contractor does? He contacts cement manufacturer, brick manufacturer, furniture manufacturer, and door manufacturer. A lot of peripherals are there. So he will contact them, and he will integrate those all different peripheries, different systems, subsystems, and he will make a main system which you want, like which owner wants. So here end user is you, means industries like Tata Motors, Ashok Leyland, Mahindra, and system integrator means the person who is in between and who is the main person who is responsible for integrating the system. So who is robot manufacturer? Robot manufacturer is just a supplier of robot. He is not going to supply tooling, he is not going to supply the fixturing or jig, or he is not going to supply any sensors. So sensors you need to procure differently and robot differently. So you just remember these three terms: who is robot manufacturer, who is system integrator, and who is end user. Why we are explaining you this today? Because you can find scope in these three different areas. Either you can, you are a student, you can either go with robot manufacturer, or you become a part of system integrator, or you can join end users like Tata and Mahindra. So here are some examples like robot manufacturers. Who are the robot manufacturers? KUKA are also one of them. So you can see examples over here like Stobli, Kawasaki. These are all reputed robotic manufacturers who have industrial standard, and even they have fan clubs also, like fan following. So differently in south area, in north area, there will be different regions for those robots. So you can see those manipulators here in picture. So if you move to next slide, this is like a block diagram where it is explaining about the architecture which I explained earlier. So here you can see, as an example, Tata Motors is the end customer. Tata Motors is the end customer who want to manufacture a car body. So in that case, what he will do, he will give order to Ushin. Ushin is system integrator. It's an example. So similarly, you can have integrators like Ushin, Goodale, Mottech, Kumau, like that. Like different integrators are there. He will give order, then his task is done. Then what system integrator will do is, he will contact robot manufacturer, because robot is a major part of that system. It's a actual moving component, and it's a major, it fills some 80% of that system. That's why he will first contact robot manufacturer, for example, KUKA robot, and he will purchase that robot. Now, when he purchased the robot is naked. It means there is no tool, there is no base, nothing. Robot is just like it's like a new car for integrator. He has to design interior, he has to customize it for end customer. So what he does, like what system integrator does is, he will design like controls, he will design HMI, he will be looking towards maintenance and support, installation and commissioning on site, retrofitting. The bubbles which are shown on the picture, the task of this is less like a small task which are represented, but the list will be at very huge scale. So after integrating these all different categories, he will be finally going to end customer for sign off and delivery. What is sign off and delivery? It means end customer will check whether his requirements are fulfilled or not. He will verify each and everything about quality parameters and about maintenance checklists, and lot of checklists will be there. He will check, and then he will finalize, okay, we received our product and we are now releasing your payments. So this is a task of end customer, system integrator and robot manufacturer. Be sure who are they, and this is only what happens here in like industrial world, so industrial robotic world. So this is how the picture represents what integrator is doing, system integrator is doing. He's a person who is not only dealing with product, but he's also not only dealing with robotic product, but also dealing with other vendors like sensor suppliers, fixture suppliers, tool suppliers, and even customized he will also customize some designs, and he will manufacture it from fabrication team. So this is a kind of work which is of system integrator. So this is how customer looks towards robot. Whenever end customer like Tata is looking towards robot, he will ask for condition monitoring, advanced position, force and material object sensing. The things which I mentioned on display, you can see these things are what coming inside their minds, and these things integrator has to resolve, and he has to finalize so that end customer will be happy with his requirements. So when we moving to next slide, you can see there are some end customer examples here like Bugatti, Audi, VW, Tata, much more people are there. Due to slide limits, we can't put all names, but it's like a vast field. So you can think about any automotive producer or any FMCG producers. Yeah. So what is technological development which is expanding robot adoption? When you talk about today, we have some more intelligent components. It means before lockdown, this is 2020, we are in 2020, so we have some more intelligent grippers. We call them smart grippers. Grippers mean what? They are used for holding and releasing components, like for pick and place applications, we use grippers. So traditionally grippers are like just open and close and send some signals, but nowadays grippers are becoming smart. It means they have feedback of force, how much force it is holding the object, and what is the diameter of that object. It is going to detect those things. So it means those are smart grippers. Then they have plug and play interfaces. Like earlier what was happening is we need to call specialized engineers, specialized technicians, so that they can make integration of gripper with the robot. But nowadays it became plug and play. It means it is similar to your mobile phones. However you purchase back cover for your mobile phone, it became similar like that. It is a very plug and play. All dimensions are there, fit to run. Like that thing are happening nowadays, like today. And easy to again use. For example, in KUKA robot also you will get an option to program it by holding in your hand. Like you can take robot with your hand anywhere. It will become free for you. It means like traditionally, no need to use smart pads, no need to use remote controls to program the manipulator. You can just hold it in your hand and you can take it anywhere you want, and that positions will be recorded by robot. So this is what we say programming by demonstration. That is easier to use. When we talk about tomorrow, it means 2021, 2022 ahead. So what upcoming days are like, we will be having some machine learning which enabling robot. Machine learning, obviously many of heard. So we are not going into machine learning how it is going to work, but what machine learning means is machine is able to detect some inputs from external world, and depending upon those inputs it is able to calculate the like output. It means how to behave, how to do, what to do next, what next, it will decide what next. So similarly we can use machine learning which will enable robots to learn by trial and error. Means robot itself will it will follow trial error method in order to selfly optimize itself, like parameter optimization, like velocity control, acceleration, deacceleration. It will optimize itself, and even to communicate with other machines to improve entire processes. So this kind of things we are thinking about, like machine learning, which are to be in future. They are not present right now, but we are thinking that it will be a future. Now what will be the next new business models, like robot as a service? Now many of you will think, what is RAS? RAAS. This is like we are putting as I shown in earlier slide. Which one? This slide. 1 second. Let me explain it first. Okay. Yeah. So when we seen in previous slide, robot having a controller, it means it is having a electronics and software also. So that software we are going to put in cloud. It means in upcoming future there will be one cloud, and entire robotic control will be inside the cloud, and cloud is just directly controlling electronics inside the industries. So that commands which are sent from cloud will be processed by electronic equipment, and then it will control the manipulator. What this will be beneficial, like it will be beneficial for machine learning again, because we are not going to monitor only one robot, we are going to monitor a cloud. It means there will be thousands of robots, and then we can optimize the parameters. We can even it will give flexibility towards integration, and for a firm it will provide the safety also, like cyber security. When we go to next slide, yeah, this will be much more interesting for all students who are entering inside engineering now, because for their upcoming third year or fourth year project they can go with ROS integration with KUKA robots. It means what? You can develop your own operating system, you can develop your own robot operating system which will be used for path planning, or it will be used for position planning, and then you can send this you can just integrate directly your operating system. You can directly integrate. For example, my name is Pawan, so I created OS called Pawan. I can integrate that Pawan OS directly with KUKA controller. It means whatever commands that my OS is sending to KUKA controller, manipulator will resemble it. So this will be flexible for people who are more interested in research kind of thing, but with the touch of industrial robots. So this will be helpful for them. You can see in the picture that we connected KUKA controller with the help of LAN cable over computer, and then we are commanding via mobile phones also. And this obviously both will be connected to internet again. Yeah. So next, if we are going towards real world industrial applications, we will be more interesting to see what is the industrial application, actual industrial application. So first we are going to see is about spot welding. Yeah. So many of you know that what is spot welding. Rather than wasting time, I will enter a video so that you can understand in animation what is spot welding and how it is done with the help of KUKA robot. I hope everyone sees the video. So here you can see in animation, two electrodes are pressing sheet metal. Majorly it is used for welding sheet metals like car body. So that sheet metal is squeezed like sandwich, and current is passed in order to have a welding. Now in picture you can also see that KUKA robots, there are multiple robots, like some 10-20 robots working on a common car body. So this is the car body in BIW line. This is one of the example from Tata Motors. So you can see how much robots are there and working together to perform a car body. And this is a complete line. This is like cars are moving per minute, one car is built up there. So this is a kind of application what we call spot welding. Once we back, we will turn to the slide. Yeah. So once you see here, we completed spot welding now. We have total 10 applications we are going to like discuss now. So second one is, this is a gun which you can see here. This is a spot welding gun. As I shown in animation, you can see there will be electrodes which are squeezing and the current is passed between them. For position control, we have servo also, like opening and closing of this jaw. We have here this servo motor also. Next is arc welding application. Arc welding application is also playing a very important role in industries, because it is improving the safety of workers, because you know that arc welding produces much more burns which we if we inhale, it is hazardous. So hazardous fumes can be avoided by using arc welding robot. So, and even quality is also improving, and repeated tasks can be done with the robot, because usually operator becomes tired or fatigued due to repeated tasks. So here with the robot is not going to tire anymore. It can work 24/7. So that gives us flexibility to use robot for arc welding. So I will play one video for you so that you can understand how it is going to help for arc welding application. So yeah, sorry for my fast thing because time is limited. We are going fast. So you can see here, programmer is moving robot. This is how he is teaching, and now you can see he is teaching with the mouse, 6-dimensional mouse. So it is very easy for operator to teach any program. Advanced programming is not required. Like no need to think about more complexity. Here you can set current parameters, voltage parameters, and that's it. Once you start, robot will perform a dry cycle. It means you need to check, and then it will start welding, actual welding, and it will do it forever, infinite. Yeah, this is a ready component which you have. Okay, so we will move to next application now. So once we are back here again, next application is material handling, and we are all talking about industrial robot here. So material handling is much more major application of robots, because handling the material becomes one of the important role in industries, because we need like cycle time need to be optimized, and components will maybe hazardous or maybe heavy. So in case of heaviness, we need robot itself, because that weight can't be beared by any labor. So now we will go through material handling video also, so that you will have an idea. So here is the video. These are our Titan series robots. They can pick up to 1.3 ton of payload. And they are working in teams. They are in team. Next application we are moving is about like painting. In industry, painting is very important, and painting needs special repeatability. And you know that whenever there will be like rework required, then it will be very thing, like very costly for industry. So we need to avoid rework as much as possible, and that can be only achieved with the help of robots. So we have some robots with especially for painting application, which are covered, which are like seeing in the picture, white color, that cover is there. They are covered inside the like this type kind of cover, and it is having a special tool which is meant for painting. It can regulate the flow rate, and it can like create a shape of different shapes of spray. So we will have video for that also. You can have a idea. So here I am starting the video. So here these robots are there, ceiling mounted robots are there, floor mounted robots are there. This brings an advantage over, like you can see this cardboard is lifted by our handling robot, and these are painting robots. If we go with next application, hope everyone understood what is how painting is done. So next is mobile handling. Mobile handling became nowadays very interesting, because much more industries like assembly industries. So I will give an example of Ford India. So what we can have like example here is for assembly line, operator are working, but they need some components for assembly purpose. So that components will be delivered with the help of mobile robots. It means robot is going to carry component for you. It will carry a carriage for you, where you can refill your component tray, so that you will continue your work. So this kind of mobile handling are also very crucial for industries. So that video is also there. You can have a look. This is our mobile KMR, KUKA mobile platform, and with the collaborative robot. So there is no safety fence on it. And it is again connected to a cloud fleet manager so that we can control the motion and position. It is using SLAM technology, SLAM. So that SAM technology is used for locating or localizing this mobile platform. That is holding component, and then it will go to the operator and it will deliver material there. You can see in the picture. And if someone is there, it will stop because it has scanner which is detecting collision. And now it is going to refill. It is going to refill the trays. This is kind of very good application of mobile robots in the industry. You can see in the picture. Yeah, back to the slide. So here, next application, sixth application we are talking about is picking, packing, or palletizing. You know, in FMCG industries like Colgate or like Lifebuoy, these are FMCG where materials like components will be packed inside the box, wooden box. So those wooden box has to be stacked each on each other so that we can it will be more flexible for transportation. So for such kind of palletizing, traditionally operator could have spent a lot of time, but now robot can do it within minutes. So you can have video for that also here, palletizing video. I'm going to play it. Yeah, see how much fast it is. So you can like how much revenue you can generate from such industries where time is like saved. This is how it is stacking. So those final products will be sent to transportation. Yeah, next slide we will start. So here, next is like assembly line. So what means assembly? Not only for big industries, but also for small electronic industries also, we have small robots. We have robots which are ranging from 3 kg to 1.3 ton. So you can imagine how much applications are possible with these manipulators. So in assembly, we will have a video. This small Agilus robot is going to assemble motherboard. So electronic industry also have boom for industrial robots. So this is what that video is. You can see. Now it is having force detection here. It means like it is going to detect that RAM, how much force it has to apply. Robot is enabled with force gauge. Yeah, when due to time constraint, we need to move faster. So next application is like mechanical cutting, grinding, deburring, and polishing. Here, robot is having robot. See, operator. There are some limitation for operator for deburring because deburring needs very stability. A small deflection in his tool may lead to a complete rework of that object or rework of that component or failure, complete scrap of that component. So in order to avoid that, we have to use industrial robot for even deburring applications. So deburring application, we can have a video here, like how it is done. So you can see in the video. This is mainly done for like engine block, for example. It is going to pick. This is ATC, automatic tool changer. It can switch between multiple tools. Now it has just conducting cutting application. And this is deburring. Deburring means we are removing the burr from engine. Yeah. So when we move to next slide, we have a application that is gluing. So gluing means what? Like you can see there is a conveyor below, red, black color conveyor, and shoe sole is moving on that. So in like this is like a real time application where conveyor is not going to stop. We need to synchronize with the conveyor and we need to apply glue over that sole. So such applications are also booming nowadays, like synchronous, in order to save the time required for such applications. So other processes also we see, application videos we are going to see now. What with industrial robot, what you can do, what you can do else. So here's one interesting video. You can impress someone with this. Here robot, like what it is doing is it is doing sculpturing, and this is done with the help of CAD softwares. It means no need to program. You just import your favorite person picture, and then robot will automatically generate coordinates and it will perform this task in order to complete the sculpture thing. Like you can see how it is beautiful. And again we want to see some application videos, like see what we did now is like just 10 applications. So there will be thousands of applications, but we can't discuss them all at a single moment. So what we can do is I will just share you one video. I'm just playing those video. We can see how much industry have a scope for
KUKA.
so here is our market. This is camera actually for photography in automotive sector. Arc welding. Food industry.
KUKA.
Yeah. As my colleague already explained to you regarding collaborative robot, which is going to work with human, like which is assisting the human, we will see one of its example here. Like I will play one video. You can see how much trending nowadays industrial robot, and in that case again medical robot.
What will medicine look like in the
We will have
future?
this video.
How can patients benefit?
What will medicine look like in the future? How can patients benefit from innovative technology?
change? Many of us have the vision that robotics will play a role in this future.
Many of us have the
Transforming
vision that
ideas into a
robotics will play
product
a role
requires
in
a
this
strong
future.
focus.
Transforming
In order to be
ideas into
successful,
a product
it's key
requires
to
a
have a
strong
strong
focus.
partner
This is medical
with
application.
experience in robotic components. KUKA has more than 40 years experience in industrial robotics,
has
with
more
over
than
250,000
years
robots
experience in
in the
industrial
field,
robotics,
providing
with
us
over
with expertise
250,000
in the
robots,
complex field of robotics,
providing us
where a lot of
with
attention to
expertise
detail
in the complex
is
field of
required.
robotics.
Safe
where a lot of
interaction
attention
with
to detail
robots save
is
human-machine interaction.
Safe
Add
interaction
an additional
with
level of
robots.
complexity to
Interactive.
the application.
Add an additional level of complexity to the application.
Yeah, this is another kind of application, like whoever want to purchase. This is a physiotherapy actually. So once you program it, it will do it repeatedly, so that fatigue on nurses will be not there. You can understand. Like, see, the robot is doing its task, and it is endless. Here it is going to have brain surgery. So it is assisting actually. So we can insert a probe inside the human skull. Now it is going to drill. So this drilling is done, and then it will insert like probe inside the brain. So such kind of repetitive, and this is a kind of repeatability, na? So repeatability matters here. A small deflection will lead to problem, and this kind of applications also can be done. This is a kind of massage. Yeah. Again, time is running, so we need to move forward. So we completed some of applications. So what is next? What is future? When we talk about next, what will be there in future of robotics? So as many of you know that artificial intelligence, machine learning, such kind of things are going to play an important role, because whenever we say these robots are till now just obeying instructions which are sent by humans, till now they are not capable to think themselves. So in order to add that capability, what we say about autonomous robots, so in order to achieve autonomous robots, we need artificial intelligence and machine learning growth. So you can think that in upcoming era, artificial intelligence, machine learning will be booming. Some of like Internet of Things, already Internet of Things is established in some of the industrial environment. We call them as Industry 4.0. So even KUKA supports already enabled with Industry 4.0. Nano robots, rescue robots, robot for defense, child care robot, law and enforcement, like replacing police, such kind of applications are also going to be booming. Then home care, security, defense applications, some space explorations, like we are sending humans to space, and it takes more cost to send humans rather than robots, because we need to arrange oxygen for them, we need to arrange food for them. So if you send robot, then we are like no issues. Robot doesn't require any oxygen supply or food supply. Only it requires solar energy. That is there already. So we can use robots for solar exploration, space exploration. Then deep sea mining, fast medical curing, and planet cleaning. Obviously, planet cleaning, like we can support Clean India now with robots in upcoming days. Yeah. So many of you will think we are discussing all about how to what robotics will do, what is future for robotics, but how to start, where to start? Many of you will think. So what you can do is, firstly you complete your graduation, and then later on when you are technically, or when you are completing your graduation, after completing or during pursuing only, what you can do is you can just start learning some industrial robotic programming languages like KUKA, Ishkawa, Fanuc, any other robotic manufacturer. Then you can attend their schools, because KUKA is also having college in Pune, in Gurgaon. So you can join there also for learning about robotics. So this robotic learning is going to have like very beneficial for upcoming days. What you will require is, you just require PC basic knowledge. And see, if you are mechanical or if you are electronic student, it doesn't mean that you should stay in that like field only, because robotics is a multidisciplinary. It means like all branches has their we need to have all knowledge of other fields also. So as you can see in the diagram, robotics is at a center. So it means all branches are having common their entry in the robotics. So if we go to next slide, you can see why to learn robotics. So we need to learn robotics for in order to an introduction to programming. So, like we can get introduction about programming, how programming is done in robotics, and then it also increases our creativity, and we'll be preparing ourselves for future, and also how innovation is done. So we can get that benefits from robotics. You can become a programmer across our, what we said earlier, like end customers. You can directly enter end customer industries, and there you can work as a programmer, because product support is different and programming support is different. So many of industry in market need your support, like need programmers for programming robot. So you can complete your graduation, you can join any training center like KUKA or any other robot manufacturer, and then you can join any firms as a programmers. So this is also very good scope for upcoming days. And as we said, human robot collaboration is also going to boom. It means robot and machine and human has to work on a same workspace, in a shared workspace. So that has also boom in upcoming days, and assisting or replacing humans in this space. So once it is done, then we'll be very successful in the field of robotics. Till it is in middle somewhere, we need to go ahead, like time is there, so we need to go ahead till so that we can even replace humans in space.